Good afternoon, I am Mr. Ish. Recently we've looked at two videos, one on domain analysis and one on range analysis from graphs. So let's take that specific concept and take it one step further, and we will do the domain and range analysis along with the equation presentation from two questions, and that will be the purpose of this video. This is very relevant material which will be presented. We have a specific depiction over here, and we have to determine the domain and range of what you see of that function, and we have to determine the relevant equations that are involved. We always start here with domain, and you always look from left to right extent of that graph and always focusing on the x-axis values. When you're looking over here, you're coming from outside the picture in terms of where the curve is originating from, so you can very clearly say it's minus infinity. It comes over here and it stops here at 0, 1, but it doesn't really matter even if it stops, because it still continues. In terms of x-axis values, in all aspects it's always continuing in the direction of right, and you can very well say it's minus infinity to positive infinity, and that domain would be right. In terms of range, you're always looking from the down to up, the lowest to the highest extent of the graph, lowest to the highest, but only at the y values. Again, this graph would be going infinitely to the left, but it would also be going infinitely down. So it's coming from minus infinity in terms of the y-axis values, and it comes over here and it stops at this value, never going higher, but this value actually falls on the function on the curve. This y value of 1 is very well found on that curve, so you can say minus infinity up to 1 and including 1, and that domain and range is good. How can we express this function? We technically have two lines. So what you can do is a piecewise function. You know that. You might have seen that word, piecewise functions. And that's what we can do, presented in that manner. F of x is two equations over here based on the domain. When we're looking at the domain over here from minus infinity but up to 0. We know we've stated minus infinity to infinity, but within this overall domain there's a subset of two domains. From minus infinity up to that 0, we end up having a equation which is a diagonal line going from minus 1, 0 and 0, 1. You can do the slope determination. You have a y-intercept of 1 and you have a positive slope, and it's equally steep, equally flat. You could easily solve that equation in terms of these two coordinate points and do your slope analysis and your equation analysis. You'll have y is equal to x plus 1. But since we already have f of x here and it's representing y, you can just say x plus 1. It satisfies the expression x plus 1 from the domain minus infinity to 0. And then we also have a horizontal line originating at a y-intercept of 0, 1, and that would be just 1. And the domain for that would be from 0 up to infinity. And to be a little bit more clear and specific, we can actually improve the parentheses over here. We can put a square parentheses here and a square over here, because in all instances these values fall within these relevant subset functions over here. And this example over here has been completed. This test question is good. The domain is minus infinity to infinity, range is minus infinity to 1, the stepwise function is 1 if you're looking from 0 up to infinity, and it's x plus 1 when you're looking from minus infinity up to 0 and including 0. And we're done with this question. Alright, let's look at the second question and the last question. We have a piecewise function here, or you can say a group of two functions which are generated here by a horizontal line and a parabola. This parabola point right over here you can say is minus 1, 1 as indicated by these points. You have to state the domain, the range, and the equations which are involved. The domain will be represented as such. You see it's coming from outside the graph. It would be minus infinity, and it comes up to this specific point, minus 1, but that minus 1 is an open value, it's not included, so we have a circular parentheses. Then from that same open value of minus 1, it continues as a parabola towards the direction of positive infinity. It's going to go here in terms of positive infinity, and the domain would be satisfied with this representation. What about the range? You're looking from the lowest to the highest extent. The lowest extent is right here, the x-axis value, and that's 0. If that's a parabola here with a vertex here at the origin, that 0 value is included in the range. You cannot say that the range is as high as 1. It's going up here in this side towards positive infinity, and this is the range value over here. The domain looks right, the range looks good. Now what we have to do is develop the functions which are involved and state them appropriately. We can state two separate parts here because they're two separate lines. We can do in whichever order, it doesn't matter, but I generally do it in terms of what the domain order. From minus infinity to minus 1, right? Minus infinity to minus 1, I'm seeing a horizontal line, and that would be just 1, y equals 1. This right here is my horizontal line, y equals 1. It goes from minus infinity and it stops at minus 1, but that value doesn't fall into that domain. And then we see a parabola, and that very well would be an x squared because it's going through the origin, and only a parabola which is x squared with a coefficient of 1 would have a minus 1 go into place of x, and it'll get squared and you get a positive 1 in terms of the output. So the equation here, the quadratic equation here, is just an x squared. And what's the domain involved over here? Just look again from here, minus 1 comma infinity, and that right there is your piecewise function. And this representation, this question, is all completed. Generally, if you had an open value over here, you have to account for something. You could probably have a closed value somewhere here outside, or something like that, hypothetically, or you could have a closed value somewhere here. For the purposes of this question, this part right here is open, and we've developed everything accordingly, and it looks good to me. And that's it for this video over here. The two questions have been presented, perhaps slightly difficult, but this is kind of the norm when you're going to 12th grade, especially or entering into college, the norm of the questions you can see. Thank you for watching. Have a nice day.